Alright, well, let's try this again. I tried it once and my recording didn't work. Um, so, we want to be able to run this for a bunch of different betas. And what I have here is that original script. And so this was that original printout that it gave with the S of t and everything. So that's kind of what we want. So now what we want to do is look at what it takes to change this over. Mostly it takes a lot of deleting, and I guess you wouldn't have to do the deleting, but I think it just makes life easier. So I'm going to go in here and I'm going to delete these comments, this comment, just so it makes everything more compact. Now here, this is where we came up with the points for S, and we don't need the plots, so I'm just going to get rid of a whole bunch of stuff down this way. I'll redo the show. Now, you know, one of these two, either the one up here, this part, you know, I need those points of S, so but they're down here as well, so I'm just gonna come all the way down here, get rid of all that stuff, and I'll fix this up. What we're gonna need are those that last point, because that last point was this 0.034. So okay, so I start with just that. So that's everything. That's everything I have. Now we define beta, gamma, alpha here. What we're going to do is I'm going to add one line that says for. So this is going to do a loop, and what I'm going to do is just define a variable, and I'm going to say it's in range. And let's just do this, say 5 times. So, and then I need that all-important colon there. But so what that says is for I in this range, now that range 5 means it's going to go 0, 1, 2, 3, 4. That's 5 numbers, 0 through 4. And I is going to take on that value for each of those numbers. And each time it takes on a value, it's going to do whatever's indented under here. And so, well, we're going to need to define beta. Now I could comment this one out. I don't have to, because as soon as I define it here, it's redefined. But so I have my beta, and what I need to do for beta is just kind of think of it as, where do I want to start? And so gamma was 0.5. You know, I could start here at say 0.2, something like that. So I could start with 0.2 and then plus, and for each of these numbers I'm going to go up some, and so I'm just going to take I times and then whatever I want to step up by, and suppose that's also 0.2, so 0.2. And so what this will do is it'll give me 0.2 plus 0, and then 0.2 plus 1 times 0.2, so 0.4, and then 0.2 plus 2 times 0.2, so 0.6, and so it's going to just march up through beta that way. So that's really all I have to truly change here. Now this, though, I need to indent it, because every time I change beta, I want to redefine my differential equation system. And then each time I redefine the system, I want to resolve it, so I'll indent that. Then every time I solve it, I want to get those points again, so I'll do that. And then finally, what I need is that number. Now, what would be nice though is eventually, you know, I want to know what beta is as well as this. So what I'm going to do here is I'm going to say show beta and that number. Now, I could just do that and run it, but it takes a little while to run it, and so I'm not going to do that. But if I did, what you'd find is, yeah, it gave me beta and this number, you know, like this one here, but the problem is it'll push them right together. I mean, it will put no space between them, anything like that. And so I'm going to do one more little technical thing. I'm going to define a text comma this way. I'm just going to say, oh, well, oops, I'm going to put a space here, just to make it look a little better. So there's a comma in quotes, so that's a text comma. And then what I'm going to do here is just say, I'm going to put that comma in between those, and it will print then that comma in between those numbers. Okay, so I think it's ready to go. Hopefully it runs, and if I evaluate this now, it takes a moment, but little by little we'll hopefully see our beta and limit pairs come out here. So there we go. There's my 0.2 and it's 0.998. And as it's talked about, when that beta is smaller than gamma, we get these numbers really close to 1. But then as soon as we have beta larger than gamma, we start getting nicer numbers. Okay, so there we have our numbers, and what would be nice then is to plot them. Well, so you can try. I don't know how well this will work. I'm going to do a Control-C for copy. Here's my spreadsheet. Now on mine, I think this is not going to work very well. So, you know, I say paste, and it says, you know, set the language automatic, use import, or to use for import. Okay, and I'm not sure what this does. If I go to that, it just says English. Well, yeah, it's English. So I'll go back to automatic, but notice what happens when I say okay. It put everything in one cell. So I'm going to undo that. And if you have that issue, here's all you have to do. Open up like a notepad document, just an empty document, text document like that from Notepad. You might be able to do it in Word, but Notepad will be the safest. And I'll say Control-V for paste. So there I just pasted my number. So it looks like I haven't done anything, but for whatever reason it does matter. So now after I've pasted them, I highlight them again and I do a Control-C and I copy them again. Okay, so this is a new copy. If I, you know, to prove it to you, I'll say copy here. You know, so that's a new copy. Now I go back here and I do a paste, and all of a sudden it asks me, is this the right way? Now, you know, this came up with comma. That's because I've done it before. If it had nothing like that, notice, you know, that's not what I want. It doesn't have a line in between. It's not putting them into two cells. If I said tab, it still doesn't. You know, comma, there it does, because I had a comma in between them. And most spreadsheets all work the same way. They'll probably ask you, although Excel might just do it straight from Sage Cell straight into Excel. So I say OK, and there are my values. And the nice thing, see, is once I have them in Excel, it's really easy to then plot them. So I can say insert a chart, and scatter plot is what I want, and I'll finish that. And so here again you'll see that these these are a problem. This is really big here. Let me make that smaller. So that's a little better looking here. So what's nice about putting them in the spreadsheet is you know, it's very quick and easy to deal with this. Now, you know, what you'll find is, yeah, these two first numbers, they don't work well. You know, here's this nice shape here. It is sort of making an S shape, but you really don't want those numbers in there. And so I'm just going to simply get rid of those numbers. And so now we have that. And if I, in my case, I have to say to edit this thing, usually you don't in something like Excel. But then if I place my mouse over one of the points, I can do an insert trend line by doing a right click. And here probably it makes sense for a power function because it's like something like 1 over x. So I'll say a power function. I'll have it show the equation. I can have it show this r squared. Well, I'll talk about it after it comes up here, so I'll say okay. And there we go. Now this r squared of 0.9999, it says that of all the variation in the data, the fact that this one's higher than that one and higher than that one and so forth, so the variation in those y values, 99.92595 and so forth. So basically almost 100% of that variation is explained by this relationship here, that y equals 0.2 x to the negative 2.7-ish. Okay, and so yeah, we see that it looks pretty good. Now I only use these 3 data points. It's better if you use more data points, but you can do that simply by coming in here and deciding, and actually I ask you to use particular values in the guided project, but you know, I can tell you what I start with and how much I go up by here, so I can fix that all up, and then how many of those I do. So here I started at 0.2, went up by 0.2, and did that 5 times total to get these numbers. And you know, I think in the guided project I have you do 7 numbers, at least to begin with. But that's all there is to getting this to work that way. It's mostly a lot of deletions and then adding in the for loop and doing the indentation. Now later I suggest you change gamma. You know, you can do that certainly right here just by, oh, I can change that to 0.4 and run it again and see what happens. So there's my 0.5, and if I want to change them both within the loop, yeah, all I have to do is come in here and say, oh, gamma equals something, and you know, so actually what I might do, you could do it either way, but I don't know, I find it a little easier to, since gamma is the smaller number, to make things work right. You know, I could do something like that, and then I could say, oh, well, I'm going to let beta equal 3 times gamma, you know, something like that, and just see what happens when I do that. So I can change gamma and have beta equal 3 times gamma and do that. But that's the, you know, that's the idea in changing up this script. Like I say, mostly you delete a bunch of stuff. You know, these 3 lines here are exactly what I had in, and I just deleted the things around them. I needed to show the numbers. Again, the comma here was just to get that comma in there so that I could paste that into an Excel file to get the plot there. Now I could plot it within Sage, but what's really nice about Excel or some other spreadsheet is I can very easily, again, remember, I can do this insert trend line idea and try out these different things. I can try logarithmic, exponential, power, polynomial, moving average. We won't do that, but in addition to the linear, and it's just really quick and easy to do that, and so that's a really nice way to get a formula for a relationship between some x and y variables here. Okay, so again, this hopefully helps you out with generating such numbers. It's really not too bad, and so good luck with that, and certainly let me know if you have any questions or get stumped on something.